You're welcome to our physics class. We are happy to have you in class today. If this is the first time of coming across our video, please subscribe to our YouTube channel and follow us on Facebook. Okay, now today we are looking at dimensions in physics. I think many of us would have heard of this topic, dimensions. Okay, in the process of looking on this topic, dimensions, we'll also be discussing fundamental quantities and derived quantities. Now, what can we say dimensions are? Okay, dimensions are physical quantities, okay, that can be measured and can be used, okay, to describe the direction in which objects move and exist. Okay, we can use them to measure the directions in which objects move and exist. Now, dimensions are derived from the fundamental quantities. Take note that from the previous definitions, you were meant to understand that fundamental quantities are basic quantities. These are basic quantities. They are usually existing on their own. Okay, they're independent. Okay, they don't depend on any other quantity. All right, they're independent. We have up to seven of them, okay, which we use as quantities under dimensions to now describe other quantities which we call derived quantities. Okay, now the major fundamental quantities we use in dimensions, okay, we have mass. Okay, mass is usually okay as m, written as m. um we have length. Okay, we use L for length. And we have what? Time. Time. We use T for time. Take note their units are quite for mass, the unit is kilogram. That's also a fundamental unit. Okay, and then for length, the unit is meter. That's a fundamental unit too. The fundamental units are derived from the fundamental quantities. Okay, and then we have time. The unit for time is seconds. And but in determination of objects in terms of how they move, okay, and they exist, we now use MLT. M is for mass, ML is for length, and T is for time. Okay, now we use that to describe most especially the derived quantities. Derived quantities here are dependent quantities. They are dependent quantities. They can't exist on their own. They have to. They are formed by a combination of the fundamental quantities and the fundamental units. Okay. For example, now we have an area. We have a lot of them. Most other, apart from the seven quantities that are fundamental, the other quantities are derived. They are derived from the fundamental quantities. So we have area. Area is length square. Okay, and if we take this m now from here, okay, that's meter for length. Okay, you take note. That will be m times m. So the unit for area will become what? L square. We have volume the same way. Okay, that will be m cube. We have many others. We have acceleration. Okay, we have velocity. We have momentum. We have force. We have power. Okay, there are many other quantities in physics. Okay, that we're going to be looking at, and we set meant to understand that these quantities and their units are under derived quantities and units. I hope you're enjoying the class. As I said earlier, just kindly subscribe to our YouTube channel, the Supernovas TV, and follow us on Facebook, the Supernovas Academy. We're also on Instagram. Okay, just so we'll learn together. We teach mathematics, physics, chemistry. Okay, the core subjects that students find very difficult. And if you're a Jambite, please subscribe because we're going to be releasing more videos for those preparing for WIC and Jump. So let's go ahead. Now we'll try to use these fundamental, these dimensions which we got from fundamental quantities, okay, to now describe derived quantities. Okay, we'll basically be using the MLT. Okay, I would like to wrap off what we have here. I hope you're paying attention. So let's go properly into dimensions. All right. So So we have question here, which the following questions state the dimension of the following. Okay, state the dimension of the following. We have volume, we have acceleration, we have work done or just work. Okay, can just put as work done. Okay, now let's go over to volume. Volume is a derived quantity, as we know, all right, and the formula for volume, okay, length times breadth times height. So we can just put it as LBH, and each of these quantities are also measured in meters. So we can also see this as what? L cube. Okay, this is can be L cube, and therefore bearing in mind that we are dealing with meters here, okay, it means this can be what? M cube. I hope you're following. Now, if we go back to dimension, we say L length, we use what? L. Take note. So it means the dimension for volume will be what? L cube. Okay, or we can also have it as M. I'm trying to, okay, M0 L cube T0. Okay, T raised to power 0. That's no value for this because M raised to power 0 is still 1. So we can say this is the dimension for what? Volume. Now let's go over to acceleration. What is acceleration? Acceleration is the change in velocity of an object with respect to time. That is the rate of change of velocity with respect to time. Okay, therefore acceleration is change in V over t. Okay, the time taken for that change to take place, that is acceleration. I will likely walk up and solve that of acceleration here before we go over to work, in which I will have to rub off the board, so we'll have some space to simplify that. So you take note that to get the dimension for any physical quantity, you have to know the formula. Okay, so many science students don't want to know all these formulas. Say it's too difficult. You have to know the formula. So I've written out the formula for acceleration, change in velocity per time taken. Okay, now velocity is rate of change of displacement in respect to time. That's velocity. So V, you can say d over t. Now from the formula now, we can get the units for V. V, this is meter, and this is what? Per second. Okay, it means acceleration. Okay, let me rub off this part so we'll just simplify that of acceleration before we go to work done. It means acceleration A equal to V over t will be equal to meters per second over second, which is time here. Okay, this would have become meter per second square. Now, going back to dimensions, it means, remember our M is L. The meter is what? L, that's length. So going back to dimension, we'll have LT minus 2, which is the same thing as M0 LT minus 2. Okay, that is the dimension for acceleration. Now, let's go lastly to work done. Let's go to work done. I will have to run off everything here. Let's go over to work done. Work done. What is work done? Okay, work done is equal to force times distance. Work done is force times distance. Okay, we have to break down these formulas so that we can get the dimension for work done. Work done actually has a unit joule, which same thing as energy. Potential and kinetic energy. Kinetic energy is 1 over 2 mv squared. Potential energy is mgh. They have the same SI unit. Okay, so which means they will likely have the same dimension. Let's try to get the dimension for work done first. Firstly, we know that force is equal to what? Ma. That is force mass times acceleration. And mass here is kilogram. While acceleration, as we just got here, is what? Meter per second square. Okay, now times, so W is now equal to kg meter per second square times meter for distance again. I hope you're following this explanation. Okay, so this becomes kg meter square because of this m per second square. I hope you're following. Now let's change it back to dimensions. Kilogram is what? M. Okay, meter square is what? L square. And per second is what? T raised to the power minus 2. This will be the dimension for work done. Okay, we can get as many dimensions, all the dimensions, we can practically use this method to get them. We have for pressure, we have momentum, we have power, we have force, we have all that. Dimension for force, we can get it here, that's M L T raised to the power minus 2. M L T minus 2. I hope we've understood that. So this is quite simple. Physics is not difficult, please. Many students shy away from that. It's difficult. No, physics is simple. Just take a step-by-step approach and you'll get all your answers. Okay, so in our next class, we'll be looking at the instrument you can use to measure length, mass, okay, weight, and all that. I hope you enjoyed this class. Thank you very much. See you in the next class.